Good evening.
Any question for today?
I do. I have a question about the
About what? I'm
homework.
sorry. Yeah.
I have a question about the homework.
What's the question?
So, for example, on problem one, the the answer are negative is of. Can you
Your voice is getting disconnected. Can you?
hear me?
Yeah. Your voice.
Hello. So my quick question is like, what answer do we choose for one, like the negative numbers? So
Yes.
we have negative 1.5, negative 2, and negative 2.5. What's
You should not have a negative. You're talking about benefit
answer we
cost
choose?
ratio analysis. You're talking about benefit cost ratio.
Yes.
Okay. You should not have a negative because what you are doing is you are subtracting the lower benefit from higher benefit, so that's a positive number, and then the cost always will be in that problem. It could be negative, but in that problem is positive because the cost of the second one, which is a lower benefit, will be less than the cost of the higher benefit ones. So when you are looking at the delta benefit over delta cost in that problem is always greater than one. It cannot be less than one because you're subtracting the benefit of for instance, you are subtracting a benefit of a B from A, for instance, and that is a positive number. And then when you do the cost of A minus cost of B, that should be a positive number. So overall will be positive. So just follow exactly what I did in the class. I did the first one. Just follow exactly that. And I didn't get a negative number on
Oh,
that.
in the example, you multiplied the benefit times P given A, and the
Yes,
bottom by P given F.
that's right. Because the benefit is annual. When it's annual, you want to bring him to present. So you multiply the benefit, which is what? Reduction in the maintenance cost plus reduction in the user cost. So those two are positive.
Oh, okay. And would it be the same? Would it be the same concept for annual worth?
What do you mean by annual worth? No, annual worth is different because annual worth, what you are doing, you are making all the benefit annually, all the costs annually in the annual worth you negative because if when you get a negative that means your cost exceed your benefit, and that's possible and it is going to be negative, but in the benefit cost ratio it doesn't get negative. So on the annual method or in the present worth analysis that we did, you can have a negative. It could be negative. So when it's negative, means that is a cost. Okay. If it's positive, means it's a net profit. Do you understand what I'm talking about?
Yes.
Okay. So on the annual method, or on present worth analysis, you can have a negative. Because if it happened negative, that means your cost exceed your benefit. So, which is fine. So you go with the lower cost, which is the lower negative one. Okay. And that is always positive. Okay. Any other question?
Okay, sounds good. Thank you.
All right, no problem. Any other question? We'll go over the problems next time if you have a question. So we can answer those any other questions that you have at the next meeting. All right. So let's talk about what we left out last time. We were talking about chapter 4, if you remember, chapter 4 of your textbook. We were talking about volume. We did talk about volume. What is the volume? And we did different volume, if you remember. We did the AADT. We did the ADT. And we did the PCAR. The directional design volume. Okay, we did all that. And we talked about PCAR factor, how you get that. And we talked about rate of flow. So we did all that last time. Now, next thing I want to talk about is about the speed. Another element of traffic flow is the speed. There's two types of speed. One is called spot speed. And the other one is called space mean speed. And then if you get the spot speed, if you want to get the average, we can call it time mean speed. All right. What would be the difference between these two speeds? Spot speed is that at any spot, if you record your speed, that's the spot speed. Now, if, for instance, a police is catching you with the radar, recording your speed at that point, that's the spot speed. Now, time mean speed means that the average speed. So, average speed, let's say you have 3 cars. The first car drive 40 miles per hour. Okay. Second car, 60 miles per hour. Okay. Third car, 50 miles per hour. So how do we get the time mean speed? We just add these together. And then time mean speed is equal to that summation over n, which is the number of observation. So in this case, will be 150 divided by 3. So that means your time mean speed is 50 miles per hour. On the average, people going 50 miles per hour, like any other average that we get. That's called time mean speed. The space mean speed means the speed over space. So let's say you have from point X to point Y. And then you have, let's say, 1 mile. Okay. And then you have a bunch of cars going. For instance, maybe the first car that moves from X to Y, it takes that as, for instance, as 100 minutes. Okay. Second car, 150 minutes. And the third car, 200 minutes. To get the space mean speed means the average speed over this space. So what we do is that we get the average of this. So the space mean speed would be summation of all the TI divided by N for all I from 1 to N over the distance. So in this case, you will have 100 and 200, you have 350 divided by 3 over 1 mile. So this gives you a number of seconds per mile.
Isn't it 450, Professor?
Pardon? 450. 450 divided by 3 is 150 over 1 mile. And this is a second over 1 mile. Okay, so that means on the average, they're going 150 seconds per mile. And then you have to convert that into miles per hour. So to convert to miles per hour, this is a multiplying by 5280, 1 mile divided by 3600 seconds. Okay, so you convert that to miles per hour. All right, any question on that? So to get space mean speed, you need to get the average. Usually we do feet because we don't want to get the 1 mile because we usually measure the stopwatch. For instance, we get 200 feet, for instance. Or 300 feet or 500 feet. So this will be feet actually. Okay, whatever it is, 200 for instance. All right. I'm sorry. Hold on. I did the opposite. Hold on. So it's the distance because it's the miles over time. So if I have 200 feet, that's 200 feet over 150 seconds. Okay. Then you multiply this by 3600 seconds, which is 1 hour, over 5280 feet. So you get it miles per hour. All right. Any question on that? So that's a space mean speed. Now, the next thing we want to talk about is density. And what is the density? Is the number of vehicles per mile. So if I have a street or a freeway and there are 3 cars in 1 mile. So this will be 3 vehicles per mile. That's the density. So 1 mile distance, you measure how many vehicles are going to be in that 1 mile. That will be your density. Now, there will be a relationship between, and then you know what the capacity is. We talked about capacity before. So you have to know what the capacity is too. Then maximum number of vehicles that pass a section of the roadway during a specific period of time under prevailing condition. We did that before. So just remember that capacity. What is it? The maximum number of vehicles that can go over a section of the roadway during a specific period of time, usually 1 hour, under prevailing condition. Now there's a relationship between, okay, if I call a volume, if I call them Q, and for speed is if I call them mu, and for density, if I call them K. If I have those initial for each of those, I like to see what are the relationship between them. So if I go on the traffic and measure the speed and the density. So I measure what the speed of the cars are and what would be the density at that time. So I have a bunch of points that I can measure speed and density. And I bring it to the office and I plot that. So I plot these speed and densities. Okay. And then I fit a line. Remember regression? We fit a line to go through this that balances these points. So this is my density, and the x-axis, y-axis will be my speed. So I plot that speed and density from this table, and I fit a line, the best line through it. Okay? So what is this point is called? This point is where the density is the lowest, almost 0. That means there is no car on the roadway except your car. So you can go pretty much any speed, the maximum speed, and we call that mu sub f. So mu sub f is called free flow speed. Free flow speed. That means that's the time that k equal to 0, we have a free flow speed. Now this point where the speed is 0 is called kj, and kj is called jam density. So jam density when all the cars are stopped, okay? So it's jammed, kj. So speed is 0, pretty much we have the highest density. That's kj. Now, if they ask me what's the relationship, well, how do I write the speed as a function of density? How do I write that equation? Knowing these facts. Correct. So we can say that mu is equal to This is the equation of this line, right? So the intercept is mu f minus the slope, which is what? Mu f over kj, correct? That's the slope times the k. So this is the equation of mu as a function of k. Any question on that? So if you know the k, you can figure out the mu, because the mu sub f and kj are constant. They are known. Now, another equation that we can write about is the relationship between the volume and the density. Volume and the density. So if I want to write the equation of that, so I want to write what is the equation of Q as a function of K. But in general, we knew that volume is equal to speed times density. This we always know, that volume is equal to speed times density. Obviously, this is a speed, but this is a space mean speed. That's a space mean speed. You remember we had two types of speed. The space mean speed times the density. Now, if I know that, how do I find Q as a function of K? Take the in. Well, it's pretty easy, because we know mu as a function of K. All I have to do is just put that mu into this formula here. So that will be Q equal to mu F times K minus mu F times Kj times K squared. So I just substitute mu into Q equal to mu K. So this is Q as a function of K. If I had to plot this, what is this? So this is a K, this is the Q. So what is this function? Yeah, it's a parabola, correct? So simply is this. All right, that's the parabola. Now, this part is the maximum volume. What did we call maximum volume? We call maximum volume capacity, correct? That's the maximum volume. Here, this point here is when we have the maximum volume. So this is K optimum, they call it. So that means the best K that we can get the maximum volume. This point here where the volume is 0, that means I'm standing by the roadway and there is no car passing me because the highway is jammed. This is the KJ, correct? So this is the Kj, this is the K optimum, this is the maximum, which is the capacity. Since this is symmetric, K optimum is equal to Kj divided by 2. So if I know my jam density, if I divide by 2, I get the K optimum. If I put the K optimum into my equation, I can get the maximum volume or capacity. Another way you can do it is that how you get the maximum on any type of a curve. You remember your calculus? You differentiate the Q with respect to K and find the K optimum and put it back into the equation and find the maximum Q. So like finding any maximum point on any curve. You differentiate with respect to the unknown, which is a K, and then find the K, put it back, and find the capacity. Okay? Now, the next thing I want to do is I want to find Q. I want to find the Q as a function of mu. So how do we do that? Well, you do exactly what we did before. Instead of finding the mu from this equation and replace it on Q equal to mu K, you find the K from this equation and put them here, and that you will have Q as a function of mu. So if I do that, my Q will be Kj times mu minus Kj over mu F times mu squared. So this is going to be my function. Now, if I have to plot this, I could do the same thing. Is a parabola. So I will do the plot. So we'll be here and here. Now this time I put the mu over here and Q over here. So the parabola will be like this. So this will be again maximum volume or capacity. This is going to be your free flow speed. And this is going to be your optimum speed. So the same way, mu optimum is equal to mu F divided by 2. So these are the relationship between mu and K, Q as a function of K, and Q as a function of mu. Okay, now let me give you an example and ask you to solve that example. Let's say I will say that mu is equal to 60 minus 0.5 K. I want you to find mu sub f. I want you to find kj. I want you to find k optimum. I want you to find mu optimum. And I want you to find capacity. Okay, I give you a couple minutes and tell me what the answers are. Okay, did anybody give me any answer? Can you give me some answer? For instance, what is the mu sub f? 60. Okay, good. What's the kj? 120. Okay, how did you get that? So you see, this 0.5 is mu f over kj, which is equal to 0.5, correct? So if mu sub f is 60, correct? So kj got to be 120, correct? So that's how you get it. All right. So what's the k optimum? Half of that, correct? All right. What's the mu optimum? 30, half of the mu f, all right? What would be the capacity? 30? No. There's several ways you can do it. 120? No. Several ways you can do it. One, basically, we can put these values into that equation that we had. You remember the equation that we had? For instance, we had this equation. So if I put them into that equation, so Q equal to mu F. We said mu F is 60 times K. This K will be K optimum. So the K optimum was what? 60 minus mu sub F is 60 over Kj, which is 120 times K squared. And K squared, that's the optimum density. Optimum density, that will be what? 60 squared. And you calculate that. That's one way to do it. Another way, you can put them into this formula. But if you put them into this formula, you get the mu, and that mu is the mu optimum. So you put that, the same answer will come. Or you could just say Q equal to mu K. But when you say mu K, mu has to be optimum, K has to be optimum. So K optimum was 60, mu F optimum was 30. So that's 100, 1800. So this would be 1800. If you put the other one, will be 1800. Several ways you can get the capacity. So this would be Q as a mu optimum times K optimum. That'll give you the maximum or capacity. All right? Is that clear to everyone?
Yes.
So if the problem like this is given to you on the exam, you should be able to do it very easily, correct? All right, so that takes care of your traffic flow section. If you are interested in traffic engineering, we have a class of CE 4740. Watch that, and it's all free. You can take it. And that's what we are talking about, all these volumes, speed density, and all the other things that is the traffic engineering part, which is the operation part of the transportation. All right. Now, the thing that I want to talk about is, yes, I teach that too. Another thing that we want to talk about is the air transportation. We're going to talk about air transportation in a little bit. Okay? So, the air transportation, the history is that, you know, that the air transportation began in 1903 when Wright piloted the first heavier than aircraft at Kitty Hawk North Carolina. The length of that flight was about 35 meters. And if you compare that to the wide span of the modern jet today, you needed the two flights to go from one side of the wing to the other side. So that gives you kind of a perspective of what was the length of that flight. The first scheduled airline flight took place in about 1914. And the duration of that flight was about 30 meters. 30 minutes. Which the same thing you could have drive by automobile about 6 hours. Now, mainly the development of the and growth of the aviation really started in both World War I and II, because the transportation of military equipment was very important. So the growth of the air transportation happened during those two wars. Now, what are the uses of air transportation? Basically, the use of it is, one, is commercial. Air transportation. And then we have the general aviation. And then we have military. So these are the uses of air transportation. On the commercial air transportation, there are several types of air transportation. So we have international, scheduled air carrier, we have international charter air carriers, and we have domestic trunk carriers, and then we have domestic local carriers, and then we have third level carriers. Okay, so these are different types of commercial air transportation. International scheduled air carriers, these are the airlines that mainly they travel internationally. That's the main function of them. And there are many of them. And in the old days, they were more specific, only international. Now they are mixing a little bit with the domestic, but mainly the function is international schedule. International charter carriers, Basically, these are the airlines that being hired by a company or a group of people to travel from a point to point. There's not that much of there's a flexibility in schedule, and usually they are cheaper and so on. Domestic trunk carriers are the main air carriers that travel within the US or in the country, such as, for instance, United, Delta, Southwest. These are all domestic trunk carriers. Domestic local carriers are smaller companies that are operating locally. Like we had several of them in state of California. They were just traveling within the state of California or just maybe Arizona a little bit here and there, but mainly very local carriers. And third level carriers, they are a smaller company again. And helicopter is part of the third level carriers that carry people from point to point or sometimes from downtown to the airport and things like that. So these are the uses of commercial air transportation. Now, on general aviation, we have general aviation for businesses. We have the general aviation for recreation. And personal purposes. And or for industrial and commercial. Okay, so that's the general aviation. So general aviation, mainly they are a smaller airplane that you can rent or hire. A lot of businesses or corporations, they have their own airplane. So those are considered the general aviation for moving like president, vice president, financial officers from one point to another point. Those are private airplanes. Recreation and personal purposes, people just go and rent a airplane and go from city to cities for personal purposes and recreation. And then, or some people own some of these airplanes that they use them for their recreation. And then there are use of industrial and commercial. We do a lot of industrial and commercial purposes with these small airplanes. For instance, fighting fires with the airplanes, spraying met flies. In civil engineering, we do surveying, photogrammetry, surveying. We do all that with these airplanes. And then any other uses that we think is so, especially like in agriculture purposes, we use that a lot. And so these are the purposes of general aviation. And then military, it's pretty obvious what we do with that. Pretty much for use of military, we have these small airplanes that owned by the defense department going from places to fight and so on. So those are the uses of air transportation: commercial, general aviation, military. All right. Now, next thing we want to talk about is that the transportation or the air transportation system. On the air transportation system, the first is en route airspace. The second one is the terminal airspace. The third, we call it approach and departure path. And then we get to the airport. On the airport, there are different components. One is called runway. We have taxiway. We have apron gate area. We have terminal building. And then we have vehicular and circulation. And parking. Okay, so that's what we have. And in the 5, we have the airport access system. E is vehicular, circulation, and parking. All right, let's go over each of them and see what they are. All right, everybody caught up with the writing? All right, the first one is called en route airspace. So the same way that we have a network of highways and roadways on the ground, they have the same thing in the space, except that on the ground we have one network, which is on the ground, but in the space we have multi-level network. So it could be one in 10,000 feet, one in 20,000 feet, one in 30,000 feet. So multi-layers. So it's the same way like what we have a highway is the network of way to go from one point to another point. So when the airplane is in any elevation, they follow the rules, and if they want to travel from here to here, they would just pretty much use like a roadway to go. So this network is called en route airspace. There is a terminal airspace, which is similar to this, but they have a different regulation, which is very attached to the terminal. So it's close to the terminal, so they have a different rules and regulation, but it is still a network of the way or pathways to get to the terminal or to land. The approach and the departure path are the ones that are being used to depart and approach the airport. Again, these are specified pathways. You cannot just move around. You got to follow these pathways to approach the airport, or when you're departing, you are supposed to be on those pathways. So they call it approach and departure path. Then we have what we call airport. Under the airport, we have a runway. So runway is basically the main pathway that the aircraft lands. And usually we have a pathway that the aircraft lands, and there's an exit on that runway. They land here, they come through the exit, and then they go to secondary roadways or pathways. They call that taxiway. And then they get to the terminal. So the length of this runway calculation is very important, that there is enough of the length for the aircraft to land, decelerate, come to a decent speed to exit, and then go to the taxiway, through taxiway, get to the terminal. So the pavement design of this runway is different than taxiway because there's a lot of compact. So it has to be very strong. Even the lighting that they have for night are different, that identifies that this is the runway. If you have been on the airplane at night, you can notice that what color usually these are. What's the color for runway?
Is it green?
Anybody? Huh?
Is it green or yellow?
No. No, it's orange.
Ah.
So it's orange. So when it's orange, that means this is the pathway for the runway. That means you are on the runway. Now there are reds over here, and this is a threshold. The red shows that this is the point that you have to land after that. That you are not supposed to land before that. Okay? Yeah, that's for landing. And even departing too. So this is a runway. And then, what's the color for the taxiway, if anybody has noticed? No, it's not yellow. It's blue.
Blue.
Next time you are on the airplane, you can notice it. It's blue. So that means you are on the taxiway. Okay, so that's the lighting that they have at night that shows, identify what's the runway, what's the taxiway, and so on. Apron gate area. That's attached to the terminal building. If this is the terminal building, this is where the area where the airplane unload the passengers. They stay there for maintenance and then put the fuel in and so on. That's what we call apron gate area. Terminal building, you are familiar with the terminal building. Each of these terminal will be, the building that for different airline has different terminal building. Vehicular circulation and parking. And what would that be? Well, when you have an airport, when you notice that you go to the airport, let's say you're taking 405, for instance, you go to LAX and you enter, and the airport is, you got to go around and you can get exit, but there is a circulation. So usually there are like two of them. One goes faster, one goes smaller, and there are connection between them and so on. So this is the circulation, and then usually parking could be in the middle of it is the parking, or it could be on the side, the parking structures. All right. And then we have the airport access system. How to access the airport. So it could be through freeways such as 405. It could be through metro, which we are building right now to take people to the airport with metro. Could be through buses. So all those ways that you can get to the airport, we call airport access system. Some airport has a special highways that just take people to the airport. For instance, if you go to Washington, D.C., and if you fly to Dallas Airport, which is about 50 miles away from the center of the city, there is a special highway that takes you to that Dallas Airport. That's for just the airport. Has a limited access. So that is provided for the access to the airport. And even in Washington, D.C., you can even go with the metro and subway to get to the airport. Or they have special buses that take you from the airport to the center of town and so on. So all of these are access to the airport access system. So this is, the whole thing is the air transportation system. All right. So we don't have any more time, so I stop here. Next time, we'll go over some capacity analysis of the air transportation. And then when we get a little bit more time, talk a little bit about rail and buses also. So that's what we're going to do next time. And if you have any question, bring it with you so that session, I can answer all the questions before your final exam. All right. Any question before we leave?
No questions.
All right. Just study hard for this week. Hopefully you guys do better than your quizzes and midterms, so I don't have to have a pressure of passing a low grade. Thank you guys. Stay safe.